Hi, I'm Marat Kherudinov. In this video, I'm gonna show how to create so-called invariant datasets, such as terrain, land sea mask, leaf area index, and so on, or land type map. So let's say that we're gonna simulate atmospheric rivers in California, for that over the domain that looks like that. So you see, this is pretty large domain, western United States. So this is California, Rocky Mountains here, Canada here, Mexico here. So this is pretty large domain. Let's say that we want to use 1 kilometer grid spacing as the middle of the domain. It's latitude longitude grid here. So we would need something like 3072 grid points in each direction. Why 3072? Because it's a nice number as a divisible by 128, which is number of cores in one node of the Derecho supercomputer at NCAR. So it would be very efficient use of cores. And it's a conformal number. If you read the SAM user guide, you know that number of grid points, especially in X direction for latitude longitude grid, cannot be arbitrary. It should be divisible by 3, 5, and 2, 3, and 5 for fast Fourier transformation to work. So this is number. It's very nice. So we will use this number of grid points, and first what we do, we go to global data directory in our gSAM directory, and here we have already, we need to set up 3 symbolic links to, let me show them. 3 symbolic links for directories that somewhere in some different, maybe storage disk, a bigger one than your home directory, for example. So data directory, it should be called data. It points to this global data set that contains some data from which these scripts in here will interpolate to your grid. So this gSAM global data you should already be able to download from the gSAM website. Like, for example, if it's here, this is gSAM datasets and user guide. So if you click on it, you have this gSAM global data tar file. So you need to download it and install on your some storage disk. So this is this directory, and then you need to establish a symbolic link to that. How to do that you can watch in the video where I explain how to create, if you don't know how to make basic symbolic links, how to create invariant dataset for global runs. And also 2 directories, output directories. One is for binary datasets. Those will be used by gSAM to run actually model, and they will be placed in bin _d directory, which points to your actual directory somewhere. And also output directory for netcdf files. Those are used mostly by scripts, and also for quality control of your output datasets, because those binary files you cannot look at, but netcdf files they double those files, so you can actually look at those. I didn't make netcdf files as input for model because not many people are very proficient in creating netcdf files, so I wanted to make it as but everybody can create binary datasets, so I made it like as simple as possible. By avoiding using netcdf files as input, especially when you have many time steps, it can be tricky, or very large data sets. So okay, So in order to first you start with terrain. So you create first terrain data. For that, you edit the Fortran program called, or utility Fortran like make 2D ter region. This Fortran program that creates some binary data set for terrain interpolated from data and make it interpolated to your grid specifications. So for that, you specify your domain that you want to use. In this case, it's longitude of the western boundary. In our case, it's 225 degrees east. You always use the coordinates from 0 to 360, no degrees west or negative numbers, only positive number in the range from 0 to 360, and 0 being normal zero coordinate longitude. Now latitude, this is the center of the domain. In our case, it's like 40 degrees north. And number of grid points in longitude direction 3072, and in latitude 3072, and grid spacing as the center of the domain is 1000 by 1000. It is longitude latitude grid, so the resolution will be slightly varying across the domain, but in the center it will be very close to 1000 meters. Okay, so now what you do after you edited this information, you just compile it. In my case, I use gFortran because I run this test on my Mac Mini, and you need to use some relatively large memory computer for that, because those data sets that this script uses, from which it interpolates, can be very large and may not fit in your memory. I use Mac Mini and it fits just all right. So don't get surprised if your code crashes because of lack of memory. So I recommend using O3 optimization, because O3 optimization actually creates code which uses less amount of memory, usually for some unknown to me reason. And as well, it's going to be fast as well. So always use O3 if you can. So make 2D ter region. You just compile it, and then you just run it IA out. So it does its magic, creating some files. After that, you just compile similar, but in this case you don't have to edit anything, this dataset for land type, from which it will create actually then a land-sea mask and information like that. So it would know where there is ocean, where there is land, when there is lake, where there is this and that. So you just compile also with a region, land type region. You just compile it and execute. So as a result of this, you will create in let's see, in output bin D directory 3 files starting with out. See, you created out files, land type, some binary file, and terrain file, but also you will create lat long text file which has information about latitude, longitude of your grid points on your grid. Sometimes it's useful to have precise coordinates of your grid points, especially when you run actual domain. So this would your model would then read this such file, and it's very useful when it produces output from your model. Okay, so for now, let's convert those binary files into netcdf files, because other scripts will use netcdf files actually. So for that, you just need to have ncar command language, or NCL, installed on your computer. You can download it from ncar website. So NCL, and then a script is called bin to nc ter. You just execute it, and then the same for land type. So as a result, you will have in your ncd directory Also two files that start from out. But so land type and terrain, but not latitude longitude grid file, because it's already text. So you have these two files. Now you need to rename them, because they're just generic file names that if you execute script this program next time, it will override it. So you need to rename them. So let's rename them. Let's say that land type, we move it to the same directory, but we give a different name. It should start with land type, but then you give some identifier prefix that or suffix that you will be using for all other data for your domain, like say just identifier of grid size, like 33072, and also that it's California centered. So this is California dataset and C, and then you just move it, rename it, and the same thing for terrain. So it should have not ter but terrain, name terrain. Here it will be ter. Okay. So now we renamed them, and now those will be used by other scripts. So we look at the 2D in var and CL script. So here I already said this, you specify this grid and this suffix that we used, identifier, so that this script would find files that it needs using this common suffix. That's basically the only thing that you need to edit if your names of these output directories do not change, if you use the same. So here they specified, and also what I specified here is that the script should produce not only binary data sets that will be used by the model, but also netcdf data sets, netcdf out to true. I set it to true, so that I could actually check them afterwards and see what actually data sets I created, because it's very easy to look at netcdf files. Okay, so now everything is set. So make sure that this grid is specified to your correct specification of this suffix, and then you just execute it. NCL. So it will take some time, so I will pause the video. It may take several minutes. Okay, after a few minutes your script is done, and now let's see what is generated. So let's look at our BND directory. We'll look for prefix California. So you see we created these data sets. LAI is a leaf area index dataset. Land mask, it's C land mask dataset. Those datasets will be used by gSAM when you run it. It will read data from those files. Those you need to specify via name list. I will show it in further videos how to set up the name list file for this case. So now we have land type and soil, which soil file is a file that contains clay and sand content of soil in land points throughout our domain, and of course terrain file. And also if we look at netcdf directory, we have corresponding netcdf files. And you can copy those netcdf files to your desktop and take a look at them using your favorite NC viewer. I use NC View, for example. I like NC View, or you can use like NASA. What's the name for that? It's Panoply or whatever it's called. So anything that you like to use. This one is basically that I showed before. This one is using NC View, Just take a look at this terrain file. See, it looks nice. So now the one thing that is left to do is to rename that latitude longitude file that is still in binary directory. So we just move it, rename it to bin. So bin d out lat long file to the same. We leave it in the same directory. Let's call it lat long 3072 using the same prefix. California text. So okay, so now we can specify that file in our name list file as well. It doesn't have to be binary, it can be text file. We can take a look at that file, and because this one we can actually see. So you see these are longitude, so it's going from 225 down to what's the last coordinate? 225, 25. What's the maximum one? It's hard to tell actually. I think we better just more it. So you see it's going on at 3000 grid points, so that's why it's difficult to use VI for that. So it's going until it hits, yeah. So now we can take a look. So it's somewhere here. It's the last grid point 261 latitude, longitude, and latitude starts from 26.1 down to 53 degrees north. So it's you now have some idea of latitude longitude. So model will read this file and set up its grid. Okay, so basically that's it for this video. How to create initial data sets with initial conditions and with nudging data sets that your model will be nudged to. I will show in the following videos. So thanks for watching and happy computing.